students, today I am going to discuss some hot and important questions from NCERT Exemplar. Now this is question number 1, and this question is: a point positive charge is brought near an isolated conducting sphere in figure. If you see the figure, there are 4 figures given. The electric field is best given by figure 1, figure 2, or figure 3, or figure 4. So there are the options. We have one correct MCQ question. Now the point is that this is a positive charge and this is brought near an isolated conducting sphere, and then you have to see that whether the lines, if you see this second one, you know that the lines are entering here and the lines are entering from both the sides, so it's not a correct answer. Then here also lines are this is a positive charge. There can't be a lines towards the positive charge. There can't be a line towards the positive charge because it's a plus Q charge. It's a plus Q charge. It's a plus Q charge. So probably third and fourth are not the answer. Now come to first and second. In first and second, we should know that the line should be normal to the surface. This is positive charge. Certainly the line will go on this side and then they will move out from this sphere. Now how it is possible? There is a positive charge plus Q. Okay. Then there is an conducting sphere isolated. Certainly this positive charge will induce what? Negative on this side and positive on this side. So what will happen? The lines they will move like this. The lines, they will move like this from here, from here, from here. So they are going like this. Okay. Okay. And they are going like this. So certainly the lines are moving and they will come out from this side. So they will come out from this side like this, okay, like this. And this first option is correct. Why? Because electric field lines, field lines are what? Perpendicular to the conducting surface. So the first one is the correct answer. Okay, got it? They are perpendicular to the surface. This is also not right because they are not perpendicular. These two are not right because the lines are moving inside. Actually, line will move outside. Got it? This is positive charge. It will induce negative on this side, positive on this side. The lines will what? They will terminate here and they will start arising from this side. So first is the answer. Okay, so this is one correct MCQ question. One answer MCQ question. Now the next one, if you see the electric flux through the surface S, the electric flux through the surface S is given. There are charges plus Q, plus Q, plus Q, different type of surfaces. Now what it says that there are 4 options. Figure A, figure in fourth is what? Largest. Says the flux is largest. Figure in third is the least. And what is the C option? In figure 2 is same of figure 3. 2 and 3 are same and less than 4. And the last option is same in all what? Figures. Now I think this question is again from the NCERT Exemplar and very simple. The answer will be what? Same. Why? Because flux is what? Do you know? Q by epsilon naught. Flux is independent of the type of surface. Got it? So flux basically is Q by epsilon. It may be a cube, it may be a sphere, it may be any shape. Flux is basically Q by. So same in all figures. So this is very easy question. So this is a question from Exemplar. Now question number, we'll talk about question number 3. Now question number 3 is what? If there were only one type of charge in the universe. Now this is MCQ, one or more correct. So there may be more answers in this case. So if there were one type of charge in the universe, then first is that E dot ds is not equal to 0 on any surface. Second option is that E dot ds 0 if the charge is outside the surface. Third is E dot ds could not be defined. And fourth is E dot ds is Q by epsilon naught if charges of magnitude Q were inside the surface. Now I think all of you know that E dot ds cannot be 0 on any surface. This is not an option. B is right because E dot ds is 0 if the charge is outside the surface. So we know that E dot ds is what? 0 if charge is what? Charge is outside. We know this. Then E dot ds could not be defined. Again, there is no logic in this. Then come to the D option. E dot ds is what? Q by what? Epsilon naught. Okay, if Q is what? Inside. So that means B and D both are correct. So the answer here, more than one option, the answer is B and D. So very simple. If there were only one type of charge in the universe, A and C are not the right answer, but we know that B and D, we have already done in Gauss law these concepts. Now come to the question number 4. Now question number 4 is again, it has more than one option. So just see it, what it states. Question number 4. Refer to the arrangement of charges in figure and a Gaussian surface of radius r with Q at the center. Then total flux is minus Q by epsilon naught. B option is field on the surface of sphere is minus Q by 4 pi epsilon naught r square. Field means electric field. C option is flux through the surface of the sphere due to 5 Q is 0. It's outside. And D is field on the surface of the sphere due to minus 2 Q is same everywhere. Now see here, answer. One is that total flux is minus Q by, what is the total flux? Net charge inside it. What is the net charge? Minus 2Q plus Q by epsilon naught. It is the Gauss theorem. So what it will become? Minus Q by epsilon naught. That means option A is what? Correct. Field on the surface of the sphere minus Q by 4 pi epsilon naught r square. No, field will be due to the outside charges also. So this is not correct. Okay, then come to the C. Flux through the surface of the sphere due to 5Q is 0. Yes, because it is outside. So C option is also right. Flux will be 0 due to what? What? 5Q, because it is outside the surface. So this is also correct. Now D is field on the surface of a sphere due to minus 2Q is same everywhere. So minus 2Q is same everywhere. Field no. From the minus 2Q distance is not same of the surface. So it is also not correct. So A and C are the right option. Are you getting it? Field on the surface of the sphere will not be this because 5Q is also there. Field on the surface of the sphere due to minus 2Q is same everywhere. No, because the distance from 2Q is different for the surface. So this is question number 4. Got it? So more than one option. We have taken 2 questions. Now question number 5. Now question number 5 is from exemplar only. All these questions. 2 charges Q and minus 3Q are placed on x-axis separated by a distance d. Where should a third charge 2Q be placed such that it will not experience any force? We have done a lot of numerical based on this, but today again I am going to repeat it. There are 2 charges Q and minus 3Q and they are at d distance apart. Now you have to keep what? A third charge 2Q such that it will not experience. A third charge 2Q will be nearer to the charge whose magnitude is less. So magnitude is less of the Q. So it will be somewhere here, a third charge. Are you getting it or not? It can't be in between because they are unlike charges. So say this distance is what? X. Now this is A, this is B. Now net force on this will be 0. Now force due to A will be what? On this side, say it is FA. And force due to minus 3Q will be on this side, that is FB. So we know that net force will be what? 0. So suddenly FA will be equal to what? FB. What is FA? KQ 2Q by what? Distance is x square. AFA. And what is FB? From FB? K 2Q 3Q by what? D plus x what? Whole square. So K cancel out and it is 2Q square by x square and it is 6Q square by D plus x whole square. So I think Q square gone 2 3 up. So it will be 3x square equal to D plus x whole square. Are you getting it? So this is equation which has been made here and solve it out. You will solve it out. It will be 3x square d square plus x square plus what? It will be 2dx. So solving it out, taking on that side, it will be 2x square minus 2dx minus d square equal to 0. So find out the roots of x. This is a quadratic. You will get the root of x equal to d by 2 plus minus, you will get two roots, d root 3 by 2. So this is the value of the x. But what will be the exact value? The answer will be x equal to, it can't be what, minus. So d by 2 plus d root 3 by 2. So we will take d by 2 common and it is 1 plus what, root 3. So this is the answer in this case. So see here, very simple. You took two forces, F and FB are same, and then there was a quadratic equation, and then you will find out two roots, and the final answer is what? D by 2, 1 plus root 3. So it's also very important question from the exemplar. Okay. Now question number 6. What will be the total flux through the faces of the cube in figure with side of length A if charge is q placed at, and there are four things given. 1, it is at the corner of the cube. Second, midpoint of an edge of the cube. Okay, this one. And then C is the center of the face of the cube, this one. And then D is at the midpoint of B and C. So we have four cases here. Now one by one we will discuss. The first one is that it's at the corner of the cube. Now if you see, if you take a charge at the corner, okay, say this is the corner of the cube and you have taken a charge A here. Okay, there is a charge Q at A point. Now do you know how many cubes you need to enclose it? You need how many cubes? 8 cubes. How? Because 4 cube will be on the downside like this and 4 will be on the upside. So net flux from a cube will be, do you know what? 8 q by 8 epsilon naught. Because 8 cubes will share the flux. So this is the concept for the first case. Got it? 4 on the upside and 4 on the downside. So q by 8 epsilon naught, because it is kept at the corner. So you have to enclose the charge. Now second one, it is midpoint of an edge of the cube. So again I am drawing a cube and say this is a cube and it has been kept at the midpoint. Now this is the midpoint of the edge. Say this is B point. You know, to enclose it, how many cubes you need? 1 on this side. So 2 cubes on down and 2 on up. So net flux will be what? From single cube will be q by 4 epsilon naught, because 4 cubes are required. 2 on the down and 2 on the up. So 4 cubes will share the electric flux. So this is the second case. Got it? So when you keep it on the center of the edge, so you need 4 cubes. Now the center of a face of the cube. Now center of the face of the cube means that again you take a cube and this time you have kept it at the center here. Okay, this is the center. Now how many cubes you need? You need another cube for here. Only 1 cube extra. So what will be the flux? Flux will be what? Q by 2 epsilon naught only, because 2 cubes share the electric flux. Simple. So this is, and then last case was what? Do you know? It was that a point is taken at the mid between this C and this B. There is another point D. So you have taken a D point. Now how many cubes you need? Again you need only what? 1 cube. Are you getting it or not? So again the flux will be what? Same. q by 2 epsilon naught. Here also two cubes share the electric flux. This is the concept. So how we are going to solve it? So in this way, this is first, this is second, this is third, and this is fourth. So all four questions are clear. So how many cubes are needed to what? To share the electric flux. So from a cube here, q by 2 epsilon, from q by 2 epsilon naught, first one q by 8, and then it is q by 4. Okay. Now question number 7. Now question number 7 is again the very important question from the exemplar. Two charges minus q each are fixed and separated by a distance 2d. A third charge q of mass m placed at the midpoint is displaced slightly by x, okay, and perpendicular to the line joining the two fixed charges. Now you have to show that q will perform SHM. It will go up and down, and it has this time period. So how it goes up and down and how it will be. You know that if you see this q charge, it's kept here. So it will oscillate. How? Because this is minus q. So both will apply a force on it. Are you getting it? It will apply a force on this side. This is again theta. And this is x, this is d. This distance should be what? D square plus x square. Again it is also d square plus x square. So that means two forces are acting like this on this charge. Okay. This is theta, this is theta, this is f, and all of you know that these forces will have component. It will be what? F sine theta, it will be what? F sine theta, it will be what? F cos theta, F cos theta. So what is the net force? These F sine theta, they will cancel out. Okay, F sine theta. Only net force will be what? 2F cos theta. So this is the force acting on what? The charge Q. This is net force. So can we find out what is F? Yes, F is K Q square, and what is the distance? This. So it will be root d square plus, so it becomes d square plus x square. So this we can write. So net force will be 2k q square d square plus what? X square. And can we find out what is cos theta? So cos theta is here. You see cos theta is x upon root d square plus x square. Got it or not? Base upon hypotenuse. So cos theta is what? X upon root d square plus x square. So finally this force becomes 2kq square x and d square plus x square to the power what? 3 by 2. Okay, so very easy. 2f cos theta, then cos theta you put it here. Now the net force, if you see net force is 2kq square x by what? D square plus x square to the power what? 3 by 2. This is the net force. And all of you know when it will have an acceleration, you can further elaborate it. K is 1 upon 4 pi epsilon naught q square x d square plus x square to the power 3 by 2. So 2 it becomes 1 upon 2 pi epsilon naught q square x d square plus x square to the power 3 by 2. This is the force net coming. Now all of you know what is acceleration. Acceleration is force upon mass. So if I put it here, it will be 1 upon 2 pi epsilon naught m q square x by d square plus x square to the power 3 by 2. Now all of you know that at x is less than d, so x square is what? Neglected. All of you know this. So acceleration becomes 1 upon 2 pi epsilon naught q square m what? D cube into what? X. See here. So acceleration is directly proportional to displacement. Do you know what it proves? It what? SHM. And all of you know acceleration is omega square x. So we can compare it. What will be omega square? Omega square will be 1 upon 2 pi epsilon naught q square by m d cube. And finally omega is root 1 upon 2 pi epsilon naught q square by what? M d cube. This is omega. And can you get time period? Yes, omega. Omega, we all know that time period is 2 pi by omega. So we put it here. So it will be 2 pi root 2 pi epsilon naught md cube by q square. This is time period. If you take 2 pi inside, final answer will be root 8 pi cube epsilon naught md cube by what? Q square. So this is the final answer. This was the time period asked in this question. Very important how the SHM takes place. There are two forces cancel out, then you finally find the net force and then acceleration from that force, and then finally omega square x, you compare these two, and then omega and then time period. So this is the question for the time period. Okay, and then I have the last question here, question number 8. Question number 8 is just see here, total charge minus q is uniformly spread along the length of a ring of radius r, and a small test charge plus q of mass m is kept at the center of the ring and is given a gentle push along the axis of the ring. This is the diagram. This is the ring minus q charge. This is small charge, test charge, and it has been given a push. So it will what? It will oscillate. The same question like that, and then we have to prove that it executes SHM. It oscillates. So you oscillate, it will do it and obtain its time period. So there is a ring and there is a positive charge. It is just z distance. Now, how many of you remember that what was the electric field due to the ring? You remember or not? Yes, directly I am going to write, we have derived it. At this point, what is the electric field? You remember 1 upon 4 pi epsilon naught q, this is the charge, into the distance from that qz upon, you know that it was r square plus z square to the power 3 by 2. This was the electric field at this point, and because it is negative, so it will be the downward direction of electric field. So this is electric field. Again the same thing. When this is electric field, what will be the force on the point charge? QE. So can I write 1 upon 4 pi epsilon naught q, and now it is qz by what? R square plus z square to the power 3 by 2. Very simple. Same way. This is the force. And do you know here z is what? Less than r. So z square is again neglected. It is the gentle push we have given. So for the small, so 1 upon 4 pi epsilon naught qz upon what? It becomes r cube. Now this is the concept. And all of you know what is acceleration of force by mass. So acceleration will be 1 upon 4 pi epsilon naught m qz by what? R cube. This will be the acceleration for this one. And you know that acceleration is now directly proportional to z. So that means it follows what? SHM. So can I find out the time period? Yes. Acceleration is directly proportional to what? Z. So it is SHM, and acceleration is omega square z. So what will be omega square, the remaining part? So omega square I am going to write is omega square will be what? Q upon 4 pi epsilon naught mr cube. This will be, so omega you can get is root q by 4 pi epsilon naught mr cube. And do you know what is time period? Is 2 pi by omega. So I am going to put it here. So finally I am going to get answer for 2 pi in bracket 4 pi epsilon naught mr cube upon what? Q into q. So these questions are very important. They all are from exemplar. How you calculated, you know the ring's electric field, you know the force. Again you compare it like we are doing in class 11th, and then this comparison is what? Acceleration is proportional to z, and then finally you got the time period. Okay, so these are the questions from the exemplar. Practice them, and thank you. Regularly watch my videos.